Hi, welcome to the final presentation of the AKURA platform. So let's start with the introduction. So this is the group details. The one who's presenting right now is Nilesh Jayanandana and the rest of the group members are as shown on the screen. And let's go into the research problem. So understanding the problem. So right now, currently, if you look at the cyberspace, the internet is filled with lot of textual data, lot of unstructured raw data, which could be used for so many things if used properly. For an example, if you take a company, organization, all the organizations, they value the quality service, right? Quality assurance is one of the top priorities of many organizations. But to do quality assurance, they need the feedback of the customers. All right, so to get the feedback of the customers, they conduct various surveys, they analyze stuff. So but the gem here is like the crown jewel here is that all the customer feedback, all the survey results, everything, all of those can be achieved if you know where to look on the internet. So there are a lot of threads, there are a lot of blogs, there are in social media, there are hundreds and thousands of comments, there are reviews. So if you could mine this data, and if we could extract the data that we need properly, the unstructured data, if we could structure them somehow, then it will be very valuable for the organization, for organizations. So that is a problem, right? So right now there exists no such solution or framework that would enable to extract these unstructured data from the internet and then convert them into something meaningful, something knowledgeable, so that the companies could make better use of it and assure their quality, increase their quality, or do something meaningful with it. So that is the problem we are addressing with our research, AKURA research. So let's see what is AKURA. So AKURA stands for Automated Knowledge Understanding and Recognition Assistant. So that's the name we have given. So in our website, it says that in AKURA platform, it's very efficient, high performance, and it's a generic platform to streamline and build all your ideas related to raw textual data. So if you go to the next slide here, AKURA provides built-in toolkits. So we will get back to that later. And yeah, finally the last catchphrase of ours is for developers by developers. So AKURA is also, we have open sourced it, so I will get into all those details later on. Alright, so from prototype to product, so in AKURA we have several components. So as you can see, there's content scraper, NLU engine, JSON to OWL ontology parser, ontology merging, a website representing our platform. We have done a proof of concept as well, and then we have developed a couple of playgrounds called AKURA tools, so that you can test it out. It's a test environment. You can test out how to put your input and how the output is generated. So we have developed all of these. And before we get into standards and best practices, let me go ahead with what the main components of the AKURA platform is. So as I said, AKURA is a platform developed so that these organizations can actually send the input and get an output of their requirement. Like, there are four components here. The first one is the content scraper, which is responsible for scraping raw data you need from any domain in the world. So you can configure it the way you want, and you can actually get data from it. Like, for an example, if you want to say you are the owner of Samsung mobiles and you want to know the comments, the customer reviews of the Samsung J7 phone, all you have to do is give the link of the Amazon link of Amazon. Amazon is a vendor, e-shopping platform. So if you give the J7 link of the Amazon here, and if you configure the content scraper to actually, if you tell it to get the reviews, it automatically gets the reviews from the system, from Amazon, and yeah, it gives back to you. So that's the first step. All right, so all of these four components are separate, completely separate. They are not dependent on each other, but all four of these you can actually use them in a way so that you can build an amazing project using only four of these tools. But I right now I'm explaining the individual parts of it. So that's the first one was the content scraper. The second one is the NLU engine, where the NLU engine is about extracting entities and identifying semantic relationships between entities. Like for an example, if you if you enter a certain text, if you enter a paragraph, NLU engine is able to identify the theme concept of it, whether it falls under electronics or what they're talking about. The main theme of the paragraph, NLU engine is able to successfully extract it, and then the NLU engine is also able to identify the main entities of the system, main entities of the paragraph, and also NLU is able to identify specific relationships, such as, say, a person says iPhone 7 is better than Galaxy S7. So NLU engine is able to identify that relationship, saying that there's an entity called iPhone 7 and then there's an entity called Samsung Galaxy S7, and then it's able to identify the semantic relationship between them, which is iPhone 7 is better than the Galaxy S7 4. So furthermore, an LM engine is also able to identify features such as, if a person says iPhone 7 camera is so good, I love it. So NLU engine knows that iPhone 7 and camera are two entities separately, but the camera is a feature of iPhone 7. So it's amazing, really. So that's what NLU engine is. I will get back. So let me demo that NLU engine right now. So if you go here, you can put you have to give the main entity, and then you have to give the sample input. So basically the main entity here is that what we are talking about. We have to give a hint to our NLU engine that this is what we're talking about, because obviously, like if you scrape data from the J7 Amazon website, we know it's J7, right? It's already given for. So if we when we give that to our NLU engine, the results are much more accurate. So let me go ahead. So let's quickly see. I'll say this is the sample text. Let's check it out. And this is the Galaxy. All right. And let me process it. So this is the tool we have built. This is the testing area, so that we can actually test. We can put inputs and we can actually test these things. So if you look here in the system log, you can see entities replaced with sentences, and then yes, this calls with Google also. This is integrated with the Google API, and then sentence list by list, the words are broken into, and then we have identified a set of entities from Google, and then after that we have identified with lists. So this keeps going step by step by step. All right, so yeah, so let me hold on till this happens. So finally finally we are gonna get the entity list, and we are gonna get the overall theme. Yes, as you can see, we just got now right now. So because we were talking about Samsung Galaxy S5, it understands the overall theme concept is computers and electronics, which has a 95% probability of it. And then we have entity lists. So a lot of entities here. S5 phone, some. All right, so some of these are inaccurate, but we are working on making them more accurate. So these are the entities that are extracted, and if you look into this final array here, you know that the features, they say that Galaxy S6 has a feature called micro SD slot, And also they say that S5 also has a micro SD slot. And then they say that phone has something called preferences. So these are the things. So basically we extracted entities and we extracted relationships between them. So this is really great, isn't it? So this is the basic demonstration of the NLU engine. So let me go ahead to the next step. Let's go to our website again. So the next one is the ontology parser. All right, so what ontology parser does? So in the organizations, JSON is one of the most popular data representative tools, data representative language available right now. JSON has actually taken over XML in most cases because mainly it's easy, it's simple, and it works so well with JavaScript. So that's one of the main reasons for the popularity of JSON. Given it has all the other properties of XML as well, interoperable, language independent, stuff like that. But yeah, so JSON, however, there's a problem compared with XML. JSON, it's limited. The data you can store, the information you can show is limited. Like you can't actually store semantic relationships with it. You can say these are data. Everything is saved as objects. You can't actually store semantic details in it. But what we did was, for organizations, like a lot of people are using NoSQL, a lot of people are using MongoDB as their main databases right now. So what we did was we wrote a tool so that you can convert a JSON object, a JSON data set into an ontology. So why is this necessary? So the reason is, like most of the companies, they want, sometimes you want to know the semantic relationships between your objects. You cannot achieve that from a JSON dataset. So if you have a couple of JSON datasets, you can easily use our ontology parser tool and convert the raw JSON datasets into complete into into an ontology which displays semantic relationships. So if you go to the playground here, as you can see, you can either browse a JSON file, or you can type a JSON data set here, and then an ontology structure will be loaded here, and you will be able to download the ontology. So let me quickly go ahead and demo this. So let's take this example. So here you can see admin staff is the department head, marketing manager, lecturers. So all of these, let's convert this and see. Okay, so as you can see, this is the final structure of the created ontology. So as you can see, there are two things, right? The person, this one is the person name, the person of class, and this is the root class. So basically, now if you look here, you have like how many objects? Admin staff is one object, department head is another object, and marketing manager is another object, lecturers is another object. But if you really look into this, all right, so department head has name, email, contact. Marketing manager also has name, email, contact. Lecturers also have name, email, contact. So essentially, semantically speaking, these are all people, isn't it? These are all people, so they should come under one class. So that is what this ontology extractor does. So see, in this class, it has contact, it has name, and it has email. So basically it knows that all of these objects, they come under one class, they should come under one class. It identifies that all of these are people and they should belong together. So after that, separating them as lecturers, marketing managers, or department head, that is something else. All right, so, and you can either press download here and you can download the ontology, but I'm not going to do that right now. So that's pretty much basically it for a demonstration of ontology parser. And for the ontology merger, say you have two ontologies you want to be merged that have the common data. Like for example, one ontology has like one on for a person named John. The first ontology, John has kids. John is married to Sarah, and John had gender which is male. And in say there's another ontology about Sarah. So in that ontology it says Sarah has two kids. So these two kids' name is John 1 and John 2. Okay, let's say like that. But yeah, after that, yeah, but now see, though these two ontologies are separate, right? But if we merge them together in the first ontology, remember I told you that John has fiance called Sarah. All right, so that is linked with the ontology of the second ontology, and it is merged, so that we can know that John has two kids, which through Sarah, and those the names of those kids are uh, John 1 and John 2. Alright, so that's basically the ontology merger. We haven't actually created playground for this, or the content scraper for playground for this, but we will demo this in our review engine, the proof of concept. So down here we say who is AKURA platform for. It says for developers. So basically, yeah, obvious reasons for developers why AKURA platform is beneficial is basically because you don't have to worry about the underlying structure. You don't have to worry about extracting data from the internet. You don't have to worry about how to do the NLP processing. You don't have to worry about how to generate ontologies. You just have to code your business logic. That's all. So that is why AKURA platform, we believe, is going to be really beneficial and really a real value for companies. For researchers, obviously, like for developers, for researchers also, they might need to extract a lot of data from the internet. They might need to process some of this data and get structured data out of it. They might even want it in an ontology. So for researchers also, this is one of the best tools that you can use. And for enterprises, like for developers, for enterprises also, they can also focus on the business logic rather than focus on the underlying structure, like use spend resources on gathering information or gathering extracting the unstructured, analyzing these things. You don't have to worry about it. So for enterprises also, this is really good. And for rapid development, like, because you don't have to do anything, you don't have to configure anything, you just have to call the APIs and then you can just get the output from it. So it is basically very good for rapid development as well. So this is our team, and we have the project. We have done something called Rev Engine, which is built using the functionality provided by the AKURA platform. So I'll get into that. So yes, the choose your plan. So we currently offer two plans. The first one is the community edition, and the second one is the enterprise edition. So these prices can be changed, but the community edition is basically companies can actually download our source code and implement it internally with their organization. Or in the enterprise edition, we provide AKURA as a service, where all the functionalities are served as a service. So all the non-functional requirements are taken care of, like scalability, like performance. Like we have made all the optimum functionality, optimum configuration for everything, so the users don't have to worry about configuration or anything. They can just call the APIs and then get the details they want and focus on the business logic they have for their application. So those are the two different plans of it. Okay, so let me go back to my slides. So let's talk about the standards and best practices we followed. Alright, so the standards and best practices were like we developed this feature by feature. Although this is very huge right now, it started really small. We focused on one feature at a time. We went on with sprints. We used the Scrum methodology in Agile, and then which gives the more high business value for the short amount of time. And then we used GitHub as we used Git as our version controlling system. We also use Git to track our issues and resolve the issues. And we have used the coding standards, relevant coding standards for the languages we have used: Java, JavaScript, HTML, whatever. So RDF standards is also used for creating ontologies and how to name them, namespaces and everything. We have used the optimum standards. So let's talk about the high level architecture. So before talking about the high level architecture, let me demonstrate the proof of concept of our application, which is Rev Engine. So Rev Engine, as you can see, is a search engine where for electronic devices, specifically mobile phones. So hypothetically, say you want to buy a mobile phone, but you are afraid that something might happen. Like you don't know about the mobile phone much. All right, so in the internet there are thousands and thousands of reviews. So one review says this is good, another one says this is bad. So you are confused, right? You don't know what to do. You don't know whether this is good or you don't know whether this is bad. But what if someone could give you exactly what are the pros and what are the cons of this phone based on all those reviews posted by different customers? That's going to be pretty good, right? I mean, if I was a user, if I'm looking for a mobile phone, that's exactly what I would need, because then it would allow me to make a more informed decision of the product that I'm going to buy. So that's what we made. So if I let's say Samsung here, I'll type Samsung and let's go to Galaxy S6. It takes a while to load. Yeah, so we have overall rev engine score, which we have done using the sentimental analysis and a lot of procedures inside. So after that, if you can see here, we have features. So says first feature is much higher resolution camera, and if you can see that, it says that it's better than the Samsung Galaxy. This camera is better than Samsung Galaxy S6 and SGH this also, and this says worse than Samsung Galaxy S6 as well. All right, so yeah, bit of a conundrum there, but as you can see, the reason behind that is basically some people have said that the Samsung Galaxy 6 S6 camera is actually better than Samsung S6 Galaxy X camera, and it's also, some have said that it's bad, some have said it's good, some have said it's bad. So that's basically what it means. All right. So that's pretty much it. After that, we have listed the properties of the uh, device as well, all extracted from the internet. We haven't hard coded anything here. So yeah, we believe this, we can, there's obviously room for improvement, but we believe this could be another game changer. Although we developed this as a proof of concept, I think this will really benefit the society so that they could actually make informed choices when they are using to buy electronic devices. So let's go into the high level architecture. So basically this high level architecture is how we develop the rev engine, or other than proof of concept. So basically the data source is here, and then you go to the content scraper, so you extract the data from now internet, and then you get an output called unstructured data. So all the reviews are given as an array or something, so that they are unstructured and they need to be processed using the NLU engine. So using the NLU engine, this unstructured data is processed, and then an entity set of entities and relationships are given out in the JSON format here, and this JSON object is then converted to an ontology using the JSON to OWL mapper, and then yeah, and then the structured data in the ontology becomes an input for the integration engine, which takes care of merging that ontology with the existing system primary knowledge model of the system, so that it allows us to integrate those two ontologies semantically, and then the and then a knowledge retrieval engine is there, which actually allows us to provide information which is displayed here. So that's pretty much is the basic process. So I already did the demo, so let's quickly jump into the non-functional requirements. So the non-functional requirements are availability, scalability, and maintainability. So maintainability is obviously achieved by proper coding standards, which I've mentioned earlier. We have inserted proper documents, and all of these are properly developed. Like we have used Maven as the build tool, and a lot of things, lot of yeah. And the next one is availability and scalability. How did we achieve this? Like as you can see in the website, we said that there are two editions, enterprise edition and community edition. So the community edition, we can't actually focus on availability and scalability because the organizations are responsible for downloading the source code and running it in their own companies, in their own virtual machines. But the enterprise edition, we have, it's provided AKURA as a service. We have focused on availability and scalability mainly by using containers. So we have created containers for each and every engine, and we have deployed it in the Google Cloud Platform where uh, in Kubernetes clusters. So you can either scale up or scale down on the requirements where necessary. So that's pretty much covered there. So in the marketing perspective, I already mentioned the community edition and the enterprise edition. And then from a rev engine also, I already explained the product's perspective, user perspective, but from the vendor perspective also, there are a lot of things that you can request and you can use. Like if you are a Samsung S7 S6 user, all right, from looking here, looking in this page, you can see what the overall rating is, and you can see what are the features, and like how many customers say this feature is good, how many customers say this is bad. Now here if you can look, that much more internal storage, all right, so it says that it's very much better than these phones, but it's actually bad, then it's a bit bad for some customers. So that's basically it. So yeah, Q&A, because this is a video presentation, there's not going to be a Q&A. So thank you very much. So that's our final verdict on the research on AKURA platform. Thank you.